Barcelona is a magnetic city, and not only because of its culture, but for its research and innovation. At the University of Barcelona, we are celebrating the installation of 3 state-of-the-art instruments covering a different range of applications of magnetic resonance, of nuclear and electronic spins. These instruments will have a strong impact in different fields, such as biomedicine, energy, and environment.
Nuclear magnetic resonance uses strong magnetic fields to study the environment of atoms, which are the targets of drugs. This new instrument in Barcelona is the first ultra-high field NMR instrument in Spain and the first in its class in Europe and the second in the world using high-temperature superconducting magnets. It's being used here to study proteins related to cancer, and also it's going to be used to characterize antibodies and vaccines used by biotechnological drugs. This instrument is going to be part of a future hub of structural biology in the south of Europe, together with cryo-electron microscopy and the neighbor alpha synchrotron.
I'm really excited to share with you the arrival of our preclinical magnetic resonance imaging spectrometer, and it's similar to the one that you would find in a hospital to look at anatomy and structure, but here in the lab we're going to use it in combination with hyperpolarization, a technique that boosts the signal by thousands of times, and with that we can see cell metabolism, which means that we can report on health disease and also in drug development by looking at how the cells are responding to a stimulus like giving a sugar. And this is the first time that is taking place here in Spain, the combination of both MRI and hyperpolarization. And we're very excited to combine it even more with something really novel, which is tissue engineering. And with that, we are trying to push all these tools towards personalized medicine.
We are just acquiring a state-of-the-art EPR equipment that is going to enhance tremendously the research capabilities of the study of paramagnetic materials at the university. This equipment is unique in the national territory because it is going to operate on different frequency ranges, X and Q band, down to liquid helium temperatures, and not only on continuous wave, which is the traditional mode, but also on time resolved modes, which are going to allow us to study the spin dynamics of materials in a wide variety of domains, ranging from bioinorganic chemistry to molecular materials, spintronics, or quantum technologies. So this is going to convert the university in a pole in Southern Europe for EPR research.
So if you want to know more, please come and join us in Barcelona for the Barcelona Integrative Resonance Symposium.